In this video, we will talk about our term project on 3D aware image composition with Poisson blending. We focus on image composition tasks in this project. That is, given two images containing two objects, a foreground and a background, we want to output a realistic synthesis image containing those two objects. Think about Photoshop, but in a fully automatic fashion. As shown above, if we simply overlay the sunglasses onto the face, we immediately see that this is not a trivial task because we need to take care of two major problems. Firstly, geometry consistency. That is, we want to transform the images to the right location with the right size. Secondly, color consistency. That is, we want the foreground image to blend into the background naturally. We found that previous works still suffer from at least one of those problems. We extend previous works into a pipeline which contains three major components. To improve the geometry consistency, we first introduce a 3D reconstruction component, which estimates surface normal from the 2D background image. Then, in the composition component, we implemented a new variant of deep spatial transformation network that has 9 input channels. The STN estimates FN transformation for both foreground and background, and is trained jointly with the compositional GAN module during the training time. Then finally, to improve color consistency, we add a blending component, which takes in the transformed output and the mask and perform Poisson blending to get the final results. Next, we talk about each of these components in detail.
So our first pipeline is to use the 3D reconstruction to get the surface normal or the spatial information. The idea is that we have found that GAN has achieved amazing results on 2D image manipulation, and which indicates that it might contain spatial information in the hidden representations. So we use this 3D reconstruction package, and we extract the surface normal vector from the model, and we use that for further geometry information provided.
So the composition is done in two parts. First, by the STN work, which takes in the surface normal background and foreground images to produce transformed background image and transformed foreground image. Then those are passed into the compositional GAN, which is a compose by decompose, which aims to first compose and then those to provide estimations of the original input. And we have a loss penalizing the estimated and the original inputs being different.
So the idea of the blending component is that in the final blended image inside the mask region, we want the edges of the foreground image to be reserved. And on the boundary of the mask region, we want the color of the background image to be reserved. These two rules gives us a constraint optimization problem. And after solving, we get the following solution. Here, the omega is the masked region and the delta omega is the boundary. Furthermore, an additional step we take is to apply mixing gradients. That is, instead of only using the gradient from foreground image, in some cases, we would also want to incorporate the gradient from background image.
So we tried out our pipeline with 134 training examples and 148 testing examples.
So this is our experiment results from the 3D reconstruction, and the surface normal vectors are in the third column and the sixth column. On the first three columns, we see the good example of this surface normal construction, and on the right-hand side, we see the bad examples. And we can see that for the bad examples, there are strong bias in the GAN inversion.
These are some example results. So the first column is the input sunglasses, the second one is the input face, the third one is the original compositional GAN result, the fourth one is using a deeper STA with the original compositional GAN, but no surface normal. And then the fourth one is our system, which includes surface normal and the deeper STN. These are some success cases. You can see that the sunglasses are placed more realistically. And these are some failure cases. You can see that our system placed them less realistically than the original. We tried to get some quantitative evaluation. So all of us acted as evaluators comparing two systems at a time. And you can see based on these numbers, our system was preferred over the original. The deeper STN version was preferred over the original. But when comparing the deep version to ours, we observe a weak preference towards ours, but it's fairly weak.
So here we show the results from our blending components, and comparing the last column and the third column, we can see that the results after blending is more realistic than just doing naive copy. And in this particular case, since we are expecting the glasses to have some level of transparency, we found that blending with mixed ingredients gives best results.
So this is the visualization results of our full pipeline. And as we can see that our results, it looks more natural than the original compositional ones. Here are also some bad results. So in conclusion, we made a full pipelines that use surface normal in deep STN to improve the compositional results and use Poisson blending to embellish the composition results. So for the future work, we think that joint training of the surface normal and deep STN will make our results better. And that's all our project. Thank you.